Hi, we're working on Chum's outlines again, page 18, number 2.7f. We're needing to multiply out the expressions in the parentheses. My first step is going to be to move the small expression to the front because it's easier to do it that way. In my opinion, it's easier to visualize and distribute my first expression into my second expression, which I will do here in a minute. So my very first step will be to distribute. And I have to distribute x onto every part of my big expression. And then I have to distribute y also into every part of the big expression. So I'm actually going to do this in two parts. First, we're going to do x distributed into x to the fourth plus x to the third y plus x squared y squared plus x y to the third plus y to the fourth. Then we're going to distribute the y, negative y, to the same expression. X to the fourth plus x to the third y plus x squared y squared plus x y to the third plus y to the fourth. So let's do the x first. X times x to the fourth, x times x to the fourth. We keep the letter and then we add the little numbers. Now, whenever my letter doesn't have a little number, I'm going to add an imaginary little one. So 1 plus 4 equals 5, and I get x to the fifth. Now I have to distribute to x cubed y, and that'll give me, let me move this guy down a little bit just so we can see a little bit better. That's okay. So now we get x times x to the third. We don't worry about the y, it's going to just stay the same because you can only put things together when they are the same. So I'm just going to bring down my y. And then here I'm going to add my imaginary little 1. And then I'm going to add 1 plus 3 gives me 4. So I'm going to get x to the fourth. Okay, now x to x is going to x squared y squared again. I don't have another y, so my y squared is just going to come right down. And I'm going to do x times x squared, add my imaginary 1, and I get 1 plus 2 equals 3. So I get x to the third Now x times xy to the third gives me, I'm going to bring my y down, and then x times x is the same thing as x to the 1, x to the 1, my imaginary ones, and 1 plus 1 equals 2. So I get x squared, and then I'm just going to mash it up with this y to the fourth. So I'm just bringing down y to the fourth, and then I'm adding in my x. It's like saying x to the 1 times, let's add an imaginary 1, 1 equals x to the 1. Because anything times 1 is the same thing, right? If I go 5 times 1 equals 5. If I go 7 times 1, that equals 7. If I go 3 over 9 times 1, that gives me 3 over 9. And then I just bring my y down. And then I'm going to put in all of my plus signs, plus, 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 plus. That's my first part of the answer. I'll worry about canceling things out later, but for now, this is what we're going to do. Okay. Next, we're doing the y, and I'm going to do the same thing. I'm distributing that y. So I'll just have that imaginary 1 in front of my x, and negative y times 1 is just the same thing, negative y. And because I don't have any x's, I'm just going to bring that right down. X to the fourth stays the same. Y times x cubed y. Now, what we're looking at here is signs that are different, minus and plus. So when my signs are different, I get minus. I don't have any x's, so x cubed stays the same. And then I have y times this y, and I add my imaginary ones. 1 and 1, and 1 plus 1 equals 2. So I get y squared. Again, nothing to do with my x, so my x just comes right down. X squared. I have opposite signs, plus and minus, right? So then my answer will have a minus. And then I do y times y squared, add my imaginary 1. And 1 plus 2 equals 3. So I get y to the third. Next, I keep my x again, and then again I have plus and minus. So my answer will be minus. And then I have y times y to the third. I add my imaginary 1, and I get 1 plus 3 equals 4. So I get y to the fourth. And for my last part, I have opposite signs, plus and minus. So my answer will be minus. And then I have y times y to the fourth. And this is 1 plus 4 equals 5. So I get y to the fifth. Now I want to find anything that is positive and negative and looks the same so they can cancel out. Kind of like if I have plus 5 and then I have minus 5, I get 0, right? I get 0. So I want to look for things that look like that. Here I have positive x y to the fourth and then negative x y to the fourth, and those will go away. I have positive x third y squared and then negative x third y squared, and those will go away because they're turning into 0. I have positive x squared to the third and then negative x squared to the third, and those go away. And then these are the same. You can switch the order of the letters. So here I have negative yx to the fourth. That is the same thing as negative x to the fourth y. All I did was change the place of them, which you can do. It's like saying 5 times 6. Actually, let's do something easier. 5 times 1 is 5. And then if I do 1 times 5, that still gives me 5. So that is why you can change the order of your letters in math. Or you can say y times x equals yx. Doesn't matter because it's the same thing as x, y. It's always going to be the same answer. Doesn't matter. And then in turn, this one can equal yx. See? Same, same. It doesn't matter the order. So I have positive x to the fourth y and then negative x to the fourth y, right? So they go away. And all I'm left over with is x to the fifth minus y to the fifth. And let me make sure that I have the right answer. Yep. As always, thank you for watching me. Send me any problems that you might want me to work out for you that you might be having trouble with in class. Have a good day. Bye.